Okay. All right, so more vectors. Okay, so this one says write a vector and parametric equations of the line that passes through a couple of points, but I want to look at my paper to see. Okay, so this one is 1, 4, and 3, 9. Okay, and this is a no calculator question. Okay, so the first thing that we're going to need to do is find our component form of these vectors, because we're going to need that kind of no matter what we do. So component form, if you recall, is x2 minus x1, and then y2 minus y1. Okay, this is called component form. And basically that's kind of a fancy way of saying, hey, how is this traveling horizontally and how is it traveling vertically, right? To get from one point to the next, I went from, 1 to 3, right? My x's went from 1 to 3. So that means I changed horizontally by 2, right? If I went from 4 to 9, that means I changed vertically by 5. So it's a way of showing you how did it change or how is the movement. Okay, so if I find that component form, okay, if this is point 1 and this is point 2, and it does have to go in that particular order, I'm going to end up with 3 minus 1 and 9 minus 4, okay, which would leave me with the component form of 2, 5. Okay, so, we're going to need that information kind of with both of these equations. So, okay, so a vector equation is basically what we're going to do is we're going to take the starting point, right, which was 1, 4. Okay, and we're going to say, all right, well, what was that, that initial point, right? What was that initial point? And then how did it change, right? So then this is the component form over time, right? And we already figured out that it's, basically this is the work that goes right there, but we've already figured it out. So the initial point we had was from 1, 4, and the x's are changing by 2, the y's are increasing 5, and here is my vector equation. Now my parametric equation would be to split it. Okay, so parametric is going to be to split it in terms of x and in terms of y. Okay, so for my parametric, I'm going to say, all right, I started at 1, and then I'm increasing 2 per unit of t. And then for my y's, they are starting at 4, and they're increasing 5 for each unit of t. So here are my, kind of two sets of equations. Okay, 36. Okay, what is this one asking to do? What is the component form? Okay, so again, we're just going to do x2 minus x1, and then y2 minus y1. And so let's see, if this is point 1 and this is point 2, we have 0 minus 2 and 4 minus negative 1. So just watch out for your double negative there. So these vectors go to the left 2 and up 5. So this correct answer should be B. Okay, magnitude and direction. Okay, so magnitude uses the formula that looks like this. It's actually Pythagorean theorem, x squared plus y squared, or like a squared b squared equals c squared, because then we take the square root. But really, this is all it is. You take the x squared, you square it, the y, you square it, take that square root. Okay, so just watch out for negative ones that you plug in on the calculator. I like to put them in parentheses, and I'll do a quick. Let me just go to my home screen here. Just a quick watch out for this. If I say negative 6 squared, it tells me the wrong thing. So just be very, 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 very careful. Okay, so when you plug this in, make sure that that negative 6 is in parentheses, okay, plus the 8 squared. So that's 100. And square root of 100 is 10. So my magnitude is 10. Now for direction. Okay, direction means I want the angle. Okay, and this is on your formula sheet, but basically what we want is inverse tan. Okay, and it's going to be the y over the x. Make sure you put everything in positive, and then we'll figure out the quadrant at the end. Okay, so let's take a look at where this ordered pair falls. So negative 6, 8. Negative 6, 8, it would be somewhere up here, right? So this vector would look something like this. Okay, and notice this is quadrant 2. Okay, so when I do inverse tan, when I use this formula, it's going to give me what we call the reference angle. It's going to give me the angle closest to the x-axis. Okay, unfortunately, that's actually not what we want. We want to know, sorry about the bell, this angle right here. So when we find our answer, our inverse tan, we're actually going to subtract that answer from 180. Okay, so we're going to go inverse tan, and the y coordinate is 8 over 6. Again, I'm putting everything in positive. So second tan, 8 over 6. 53, and make sure you're in degree mode. I think I'm still in degree mode from the last couple of problems. So I get 53.13 degrees. But that's this guy. Okay, that's the reference angle. To find the true angle, we're going to take 180 and subtract that to plop it into quadrant 3. So 126.87 degrees. And this is the angle. Sorry, that's just a messy 6. So what is the magnitude and direction? The magnitude is 10, and the direction is 126.87 degrees, and that'll put me in quadrant 2. All right, the bell rang, so I'm thinking that I'm going to have some visitors here, so I might have to cut this one, but let me see if I can get in another one. I've just lost where I am. Okay. Okay, represent graphically the vector u plus v using head to tail and parallelogram method. Okay, so graphically, remember, vectors show direction and magnitude. So the magnitude is another word for length, and then the direction, is shortening, is it northwest, or what is the degree, and whatnot. So using head to tail, and then once we'll do it with parallelogram. Okay, so we're going to start with u and add on v. So if I'm using head to tail, I'm going to sort of do my best to sort of sketch the length, and I don't know if that looks about the right direction and approximately the right length, but there I'm starting with u. And then I'm going to add on from where that one leaves off. For this one's head, I'm going to put the other one's tail, which is this guy. Boom. And notice that one's going straight to the right. So this one's kind of going straight across. It doesn't look like it's quite as long. So I have just matched them up head to tail. I've matched them up head to tail. Now my answer, right, is like, how does a bird fly? Where did I begin and where did I end? Right? So as the bird flies, it goes like this. This is my resultant vector, meaning the answer vector, u plus v. And that one's called head to tail, where you matched up the head to the other one's tail. Okay, parallelogram method, you're going to physically kind of copy 2 of these and make them into a parallelogram. And we're going to end up with the same answer. It's going to look exactly the same in the end. But again, I'm going to do my best to sketch u. Okay, and then v looked like this. It was straight across. And then what we're going to do with parallelogram method is that you actually copy it. So I did one v up here. I'm going to do one down here as well. Right, a parallelogram, we know they're opposite sides of the same. And then here's my u. And then my resultant vector, let me go blue, is still going to be from the tails to the heads. It's going to go basically right through the middle. And if you take a look, I mean, I'm not sure how perfect my angles and lengths and all that kind of stuff are, but the blue answer, right, in both of them are exactly the same. It's just 2 ways to get the same answer. Okay, let's try one more in this time window. Okay, so u minus v graphically. Okay, it doesn't actually say which way that I have to do it, so looks like I can kind of do it however I want. So let's see. All right, I'm going to take U again. And then it says minus V. So I know that plus V would go this way, right? So minus V, we're basically going to flip the arrow around. Okay, we're going to flip the arrow around. So instead of it going with my arrow facing in this direction, okay, I'm going to flip it around so the arrow actually goes in this direction. Okay, so now the problem is that I have it meeting head to head here, right? And that's the problem. So what we're going to have to do is we're going to have to do parallelogram method. This is like minus V. So U, let me do add another one here. Let me add another one here. Oops, sorry, that's not great, but you get the gist. Okay, so where are my tails? Where are my heads? So it's going to be this. Okay, another way you could do that one looks like this. Here's U. Okay, and then instead of just reversing the position of the arrow, you can actually just physically draw it going, like kind of thinking of it like backing it up one step, like starting it from here and going here. Right, so instead of going this way, I just basically backed it up one. And then if you notice, my answer, which I know is still a little bit, you know, my pictures are not perfect, but if you kind of take a look, you end up with the same result. So there's a couple of ways you could do that one. Okay, so I'm going to stop